Hello there, it's Sean. I'm going to talk you through the paper 3 exam from June 2018. So that paper I'm just going to talk you through now was actually this Tuesday the 12th of June. Normally I'd wait a bit longer until making a recording, but it strikes me that no other recordings or solutions to this video have been made yet, or if they have, I've not been able to find them. So if you're one of those people that needs to know how they've done, this video is for you. Having said that, do take this solution video with a pinch of salt, because you never know how everybody else has done, and you may have done better than you thought on the other papers. So don't use this as a tool to torture yourself with, just use it to see if you've done as well on some questions what you thought you may have done, and to just put your mind at rest. So just be absolutely sure before you watch this video if you're watching it June 2018. Anyway, I'll get on now with the first question. The first one is to circle the value of the digit 7 in 9.17. And so this first question here, we're only concerned with one of the digits. So we're not concerned with the 9, and we're not concerned with the 7. So we are concerned with the 7. We don't care about the 9 and the 1, is what I mean to say. And so what we can do is essentially forget the 9 and the 1 and replace the 9 and the 1 with zeros. The only thing we're interested in is the 7, which comes as the second decimal place. And so we can find the value of the 7 on its own by typing in this on our calculator display, 0.07. So if we do this now, 0.07, press equals, it's 7 over 100. And so the answer we need to circle is 7 over 100. And that's the first one done. Question 2, solve 3x equals 2. This is a question I'm sure you'd get on a good day, but with the pressure of an exam, nothing seems as straightforward as it normally can be. So I'm just going to write down the question again, 3x equals 2. To solve this equation, we want to have just x on its own. And so at the minute, we've got a 3 in front of the x, and that 3 is multiplying the x. If two things are next to each other in algebra with no instruction, it will always mean one multiplied by the other. So because that 3 is multiplying the x, what we could do is swap the side of it and swap the sign. Opposite of multiplying by 3 is dividing by 3. And so x would be 2 divided by 3, which of course we can just leave as a fraction, 2/3. And with a decent enough calculator, if you did do 2 divided by 3, it should put it into 2/3 for you anyway. And so the one to circle for question 2 is that x equals 2/3. Question 3, we've got different shapes, and we need to think about which one of these has no lines of symmetry. So let's just have a look at each of them in turn. I'll start with the most obvious ones, in fact. So in my head, for C, that definitely has a line of symmetry going down the middle, and it does. The semicircle for D would have a line of symmetry just going straight through the middle of it, again. Also this one, B, would have a line of symmetry going through the right angle, a straight line that cuts the right angle and goes halfway through the opposite side. A wouldn't have any lines of symmetry. A parallelogram, which A is, would never have any lines of symmetry. So that's one of the facts of a parallelogram. So we need to just circle A, because A is the one without any symmetry, without any line symmetry whatsoever. Question 4, circle the shortest length. My honest opinion of this question, not that my opinion counts for anything necessarily, is for question 4 this is quite a nasty question, because each one of these has got different units, and so you need to know your conversions really well. So the first thing I'd suggest is to convert them all into the same unit. It doesn't honestly matter which unit you pick, but I would suggest to convert them all into meters. So if you were to convert these to meters, as my suggestion. The first one, we've got centimetres. Now what we need to remember is that 1 metre equals 100 centimetres. And so to change from one to the other, because this ratio is in the form where one value is 1, the other value isn't 1, we just simply multiply or divide by the number that isn't 1. And so we're either going to be multiplying or dividing by 100. To change from metres to centimetres, going from a small number to a big number, we'd be multiplying by 100. But because we want to change from centimetres to metres, we can go the opposite way, and therefore we're going to be doing the opposite thing. And so we take our centimetre number and divide it by 100. And so 1200 centimetres, we can divide that by 100 and get what that equals in metres. So 1200 divided by 100, let's just see. We should have 12 metres. So 1200 centimetres, we've just worked out is 12 metres. Using this here as our conversion. Kilometres, we need to know another conversion. We need to know how many metres makes a kilometre. So for this one here, we need to know that 1 kilometre is 1,000 metres. Again, this is a conversion relation where one number's 1, the other number isn't 1. And so we can change from one to the other by multiplying or dividing by the number that isn't 1, in this case 1,000. To change from kilometres to metres, to go from a small number to a big number, we'd multiply this one by 1,000. To go the other way though, we'd divide by 1,000. In this case, because our distance is in kilometres, we need to change that to metres, so we'll be multiplying by 1,000. And so if we take this and times by 1,000, we'll be able to see what 0.13 kilometres is in terms of metres. We get 130. And so already we can work out that this one isn't the shortest, because 12 metres is definitely shorter than 130 metres. So this one we worked out was 12 metres, 0.13 kilometres we said was 130 metres. 110 metres is already in metres, so again we know this one isn't going to be the shortest. 12 is still the shortest. The final one we need to convert and look at is millimetres. And for this one, again, we need to know how many millimetres is inside 1 metre, and the answer to that is 1,000. So again, to change from one to the other, we're going to multiply or divide by the number that isn't 1, in this case 1,000. From metres to millimetres, we're going from a small number to a big number, so we'd multiply that by 1,000. And to go the opposite way round, we just do the opposite thing and divide by 1,000. So to change from millimetres to metres, we're going to divide this figure here by 1,000. So 140,000 divided by 1,000 gives us 140 metres. And so, of the different values we have, of the different lengths we've seen, the smallest is actually the first one, 1,200 centimetres. And so what we need to do is to circle 1,200 centimetres, because this one is actually the shortest. So one to circle is 1,200 centimetres. Question 5. We need to shade 2/5 of this grid. And so One way we could do it would be to split this grid up, if we could, into 5 equal bits. Fifths is what we're dealing with because fifths is the bottom number of a fraction, and that means to divide into 5 equal parts. So one way we could do it would be just to notice we can divide them into 5 parts going this way. So we can divide into 5 equal strips simply by just going down the middle after every 2 squares along. 1/5, 2/5, 3, 4, and the fifth at the end. So because we want 2/5, all we need to do is to shade in 2 blocks out of these 5. And so what we're after here is actually just 8 squares. So 8 squares need to be shaded in. Another way you could have done it would have been just to simply count up the squares. 2, 4, 6, 8, 10, 12, 14, 15, 16, 17, 18, 19, 20. And so we've got 20 squares in total. Another way you could have thought of it would be just to work out directly what 2/5 of 20 is, and then shaded in that many squares. So this can be done easily enough on a calculator, or even without a calculator, but anyway, 2/5 of 20 is 8. So it just tells you that you need to shade in 8 squares by using a direct calculation. Part B, you need to shade in 10% of this grid. So again, it wouldn't hurt to just count up how many squares we've got. Well, we've got 5 columns of 4, so there should be 20 squares, but if you want to, count them by all means. 1, 2, 3, 4, 5, 6, 7, 8, 12, 16, 20. And so because we want to work out 10% of this, we need to shade in 10% of 20 squares. So again with a calculator, percentage always means out of 100, and so 10% we can think of as 10 out of 100. So 10% of 20 means just 2 squares, and so the only number of squares we need to colour in here is 2 squares. So we're not colouring in very much of it at all. So as neat as you can do, just colour in any 2 squares on this grid. It doesn't need to be the same 2 I'm colouring in. Could be any 2 you'd like, as long as it's exactly 2, no more and no less. And that's question 5 completed. Question 6 is a money question. So Sarge wants to go to all 19 home games at a football club. For each game a ticket costs £28. He can, however, if he wants to, buy a season ticket. A season ticket costs £379 and gives him entry to all 19 home games. So we need to work out how much he'd save by buying a season ticket. And so how much would it cost him if he went to all the games individually? So basically, how much would he spend without a season ticket? That's what we need to work out first. So without a season ticket, let's calculate that. So he'd presumably go to 19 home games, and each one costs £28. And so what he'd do is he'd spend £28 each one of those 19 times he goes to see his team play. And so it'd be 28 multiplied by 19. That's how much it would cost him. So let's work out this. 28 times 19, 532. But with a season ticket, it costs him £379, and it gets him into all the games he wants to see. So with a ticket, just been told what it is. It's just at the side of what I'm writing. £379. So how much he saves is just the difference in between these prices. And so the only thing we need to do now is just 532 take away 379, and that'll tell us how much he's going to save. So 532 minus 379 comes to a total of £153. Quite a big saving. And so that's what we need to pop in on the answer line. And that's question 6 completed. Question 7. We need to link these different descriptions for algebra parts to the correct thing. So one's been done for us, so the formula's been done very kindly, which leaves us a few other things to do. The first thing to notice, I would say, is if something looks like an equal sign but has a third bar underneath it, that's always called an identity. That's the symbol for an identity. An identity means the left-hand side is always exactly the same as the right-hand side. With an equation, the left side might be the same as the right side if the value of x, y, or whatever is correct, but an identity is just saying that one side is exactly the same thing as the other, always. An equation does have an equal sign in it, and just normally is for solving one variable. Can be more, for example, simultaneous equations. But the most important thing is an equation has to have an equal sign in it. And so this one has an equal sign, none of the others do, and so we join these two together. An inequality will always have an inequality symbol. And so just to refresh your memory, inequality symbols will be either or facing the other way, like that. And so the only one of these things with a inequality symbol is this one, and so we join this one over here to this. And finally, an expression doesn't need to have an equal sign in it at all. So an expression is the one that's left as well. Another way of thinking of it is a process of elimination. Whatever we're not joined up must be what's left. But an expression is something written in algebra without an equal sign. And so that's how you join them up. In case it makes it easier to see, I'll just colour code them for you before I move on. That's the equation. 3x plus 2 is the expression, and the inequality is this one down here. Question 8. Jim's got 6 banknotes, and we're told that the value of each banknote is £5, £10 or £20. And so what we can do for this one is picture it as different banknotes, up to 6 of them. So what we're told first off is he can make £20 with 3 notes. And so think about all the possible ways that can happen. How would you be able to have £20 in your hand with only 3 banknotes and no change? Actually, there's only one way that could happen. The only way that could happen is if you had 2 £5 notes and 1 £10 note. There's no other combination of notes that would allow you to have £20 in your hand. The second thing it says is you can make £55 with 4 notes. And again, if you think about this one, again, there's only one way you should be able to think of that can happen. The only way this one can happen is if 2 of the notes are £20, 1 note is a £5 note, and the other is a £10 note. And so I'm just going to hide the initial notes for a second so we don't confuse them with what we've got over here. And so, looking at what we've got, we know that from making £20 with 3 notes, the 3 notes have got to be including 2 5s and a 10. So we know for definite we need a 5, a 5 and a 10. So we can put those down already. We definitely need 2 5s and a 10. And from the second part here where it says he can make £55 with 4 notes, obviously from above we need a 10, just so we've got a 10 here. But also from this we need 2 £20 notes as well for definite. We also need a £5 note, but because we've got 2 5s from what it says first of all, we don't need an extra £5 note. And so the only things we need for definite from these two separate bits here is we know that we need definitely 2 5s, we need a 10 and 2 £20 notes. So we know for definite those notes. So if you count them up now in terms of what we know, we've worked out 5 notes. What the question asks us for is what would 6 notes be? And so we need to find out that missing 6th note. And so if I just write down the notes we have worked out, 2 5s, a 10 and 2 20s, we're given some more information that will help us decide what the other notes might be. So it says he can't make £25 note. He can't make £25, sorry, with 3 notes, and he can't make £25 with 4 notes. So let's just imagine maybe the other note's a £5 note. Well, if the other note was a £5 note, could he make £25 with 4 notes? Well, if the other one was a £5 note, he could make £25 with 4 notes, because he could pick a 10, a 5, a 5, and a 5. And so the other note can't be a £5 note, because if it were, he could make £25 using 4 notes by picking a 10 and 3 5s. And so it can't be a 5er. Could the other note be a £10 note? Well, here it says he can't make £25 with 3 notes. If there was a second tenner, then he could make £25 with 3 notes, because he could pick the £10 we've already got with this extra £10 and one of the 5ers. And so the other note can't be a £10 either. So what we do know then is that the other note must be a 20. And so that's told us what all the 6 notes would be. 2 £5 notes, 1 £10 note, and 3 £20 notes. And that solves the problem. Question 9, we've got a music app with a shuffle play function, as most of them do. It means that songs are played in a random order without repeating. Ruth puts 10 songs on shuffle play. One of them is her favourite song. Write down the probability that her favourite song plays first. And so she's got 10 songs on shuffle play, and only 1 song is her favourite. Then that says that 1 out of 10 songs is her favourite song. So probability that her favourite song plays first would simply just be 1 out of 10, because 1 out of those 10 songs is her favourite. Part B, Ted is using this shuffle function now, and he puts songs A, B and C on shuffle play. And we need to list all the possible orders of songs for A, B and C. One's been done for us here, A, B and C. And so if A comes first, B could be second, C could be third, or we could have A first, and then the order of B and C might be switched. So those two combinations are all the different ways the songs could play if A comes first. But what if A doesn't come first? What if, for example, B comes first? If B comes first, we could have A and C after it, or C then A. But what if B doesn't come first either? What if C comes first? C could come first, then we'd have A and B. Or it could be C, then B and A. So those are the 6 total possible combinations you could have of 3 songs without repeats. So there should be 6 different combinations, including the one which has been done for us. So you need to write down these 5 different combinations. Question 10. We've been given a scale drawing of a Ferris wheel next to a tower. So we need to work out the height of a building. Importantly, we're told it is a scale drawing. So your exam paper in front of you might be a different scale to mine. So if you're in doubt in terms of the measurements, just check with your teacher or a friend who's got the exam paper with you. But according to my measurements, we need a ruler for this one. If you measure this Ferris wheel, just need to turn this around, you should find that the Ferris wheel, I think anyway, is almost exactly 2 centimetres. So in terms of measuring on your exam paper, the Ferris wheel should be about 2 centimetres. Whereas the big building, if we measure this one, should find that's almost exactly 10 centimetres. What we need to do now is compare the height of a building compared to the Ferris wheel. Essentially, we need to be thinking how many times bigger is the building compared to the Ferris wheel. So we could work this out directly by doing 10 divided by 2. If we did that, 10 divided by 2 would give us 5. So what this means is the building is 5 times as tall as the Ferris wheel. You should find that no matter how your exam paper is printed. This tower, this building, should be 5 times taller than the Ferris wheel. I was going to give you a more visual way you might want to picture that. It's not as easy to do in practice as what I'm going to do here, but if I just mark off the top of the tower and then show you, you can imagine it being stacked up. So one Ferris wheel we've already got. Imagine adding in another Ferris wheel, a third, a fourth, and a fifth. You should find that the tower is exactly 5 times as tall as a Ferris wheel. And so, based on that calculation, or based on that fact, we can now work out the height of the building by just multiplying the height of a Ferris wheel by 5. So how tall was the Ferris wheel? Luckily we're told that in the question. It's 130 metres. And so if a building is 5 times taller than the Ferris wheel, that's going to be 5 times 130 metres. Because 130 was the height of the Ferris wheel, and we've worked out that the building is 5 times as tall. So the final bit we need to do is just work out what 5 times 130 is, which we can do easily enough with a calculator. 5 times 130 comes to 650 metres. So this building over here is 650 metres. Question 11. Joe has a full cup of coffee and she drinks some of it. So it was 10 centimetres full all the way to the top. It's now gone down to 5. Joe says half of the coffee is still in the cup because 5 centimetres is half of 10 centimetres. Is she correct? I'm going to put it simply, she definitely isn't. Yeah, 5's half of 10, but this cup isn't a cylinder. The cup goes narrower at the bottom than it is at the top, so you need to put some explanation along those lines. So it doesn't have to be exactly as I've said it, but as an explanation, put something like the cup is narrower at the bottom. And that's really all you have to say, just something simple along the lines of the cup goes smaller at the bottom than it is at the top. And that'll do you for question 11. Question 12, about pizzas, no less. So this question really is a case of information overload and can be a bit too much, so let's just take it slowly. For part B mainly, part A isn't so bad. Anyway, for part A, it says in each week a proportion of the pizzas sold were 10-inch. Now by proportion it doesn't mean the overall amount of pizzas. It means, for example, what fraction of the pizzas were 10-inch, what percentage were 10-inch, that sort of thing. So in which week was this proportion greater? Show your working to support your answer. And so let's have a look first at week 1. So week 1 in the table, 512 10-inch were sold. So for week 1, we had 512 10-inch pizzas sold out of a total of 743 that were sold in that week. So 512 out of 743 we can write like this. So as a fraction, it'd be 512 out of 743. Now we can, if we want to, convert that into a fraction easily enough on the calculator. Simplify down if we can, it doesn't. But we can change that to a percentage by multiplying by 100. And so about 68.9% of pizzas sold in week 1 were 10-inch. We can now compare that against week 2. So in week 2, let's have a look at the 10-inch pizza sales. Well, this is a frequency tree, and the total of everything in the frequency tree goes at the beginning. And so 1,065 pizzas were sold in total. And so how many were 10-inch, I wonder? So 10-inch sales, there were 758. And so for week 2, 758 10-inch pizzas were sold. Again, this time out of, I'm putting out of in red, so you can see where the numbers go in the fraction. 758 out of a total of 1,065. So as a fraction, whatever comes after the word of goes in the bottom. So the of or the out of part can be interpreted as the line dividing the top from the bottom. And so that's it as a fraction, which we can convert to a percentage in the same way. We can write it down on the calculator, 758 over 1,065. And we can multiply that by 1,000, sorry, by 100, and we get about 71.2% to one decimal place. And so if the percentage of 10-inch pizzas sold was greater in week 2 than it was week 1, because 71.2% is a higher percentage than 68.9%. And so when it asks in which week was the proportion greater, we need to answer it was greater in week 2. Part B of this question gets quite full on. It's a 4-mark question, this. And we've got a table now in Part B showing the profit or loss the takeaway makes on each pizza. So if they have an offer, they lose a tiny bit of money. Normal price, they make quite a bit of money. So we're told, first of all, after the table, that at the end of, in week 1, the profit was £1,895.55. At the end of week 1, they spend £175 on advertising, presumably to win more business. So what we need to do is to find the profit in week 2, and then the increase in profit from week 2, and compare that against the cost of the adverts. So one thing we can do, first of all, is just work out the profit in week 2. So week 2, we're told what it is for week 1, and so what we can think of here, because we're told what the profit is for week 1, we can eliminate all the other bits of information about week 1, because it's just information overload otherwise. So we could ignore all the other stuff about week 1 and just focus now on the frequency tree for week 2. So let's do week 2. Okay, so now we've got 10-inch pizzas sold. Excuse me, 10-inch pizzas sold, 758. Now some of these were normal price, some were offer price. And so the normal price was 396. And the offer price, they sold 362 10-inch pizzas. For the 12-inch, 307 were told in total. 164 were sold at normal price, and 143 were sold at the offer price. And so what we should do first of all is work out the total profit from the normal price sales. So from the normal price sales, let's calculate these. If we sold 396 10-inch pizzas at normal price, that would be a profit of 396 multiplied by £3.74. And then if we also sell 164 12-inch at normal price, that'll also be a profit of 164 lots of £5.29 per pizza sold. So we can just calculate these figures on a calculator. 396 times £3.74 and plus 164 times £5.29. Brackets are optional. You can put brackets in the calculation, but because of BidMass, the calculator will do the multiplication first and then add them together afterwards. So what that comes to is £2,348.60. £2,348.60. And that's pure profit. Now the offer price, they're going to lose a tiny bit of money on the offer price. So let's calculate what happens when they sell these pizzas at the offer price. So offer price sales. So looking at the 10-inch, 362 were sold at the offer price. Each time that'll be a 51 pence loss. Be careful with the units, we're not talking 51 pounds, we're talking 51 pence. And so input this as 0.51. Also, for 12-inch pizzas, 143 of those were sold at a 4 pence loss each time. So the total losses from the 12-inch sold at the offer price is 143 multiplied by 4 pence, which in decimal form is 0.04. And so if we add these figures together now, 362 times 0.51, then plus 143 times by 0.04, we get a loss of £190.34. So that bears the loss. So I need a bit more space, so I'm going to scroll down slightly. And so for week 2, we can work out the overall profit by doing the profit from the normal sales, take away the losses. So the overall profit will be £2,348.60 minus the loss of £190.34. So if we just calculate this, £2,348.60 minus £190.34 gives us an overall profit for week 2 of £2,158. And how many pennies was it? I've forgotten. 26p. And so the overall profit for week 2 was £2,158.26. But the question was asking for the increase in profit in week 2. And so the profit in week 1 was obviously lower, so we can work out the increase in profit by doing the profit in week 2 subtracted from the profit in week 1. And so the next step now, we can do the increase in profit. So the profit increase is £2,158.26 subtracted from what the profit was in week 1. So for week 2 profit minus for week 1 profit will tell us the increase. And so if we just compute these now on the calculator, so £2,158.26 minus £1,895.55, we get £262.71. So the increase in profit was £262.71. I can't seem to read. The question says, was the increase in profit in week 2, this figure here, more than the cost of the adverts? So what was the cost of the adverts? We can find this. It says here the takeaway spent £175 on adverts. And so spending £175 obviously isn't a good thing, but if you compare that to the money overall made in the increase in profits, the adverts were worth it, because the increase in profit of £260 odd is more than £175 we spent for adverts. And so the final answer, was the increase in profit more than the adverts? Yes, it was, because £262.71 is more than £175. And so the final answer, after all of that working, is yes. Yes, the increase in profit is more than the cost of the adverts. And that's question 12 completed. Question 13. A car travels 3.5 miles in 5 minutes. Work out the average speed in miles per hour. So, warning signs, alarm bells should be going off a bit, because here we've got minutes. Question's asking in for miles per hour as a unit of speed. So speed, distance and time, there is a formula triangle for this, which you've probably seen before quite a few times. Speed, distance and time. So we want to work out the average speed. Using this triangle method, what we can do is just cover up what we want to work out, in this case speed. Whatever's left tells us what to do in relation to one number and the other. Distance on top, time on the bottom, means distance divided by time. So speed equals distance divided by time. But just take care in terms of the units we're putting in. Distance we've got in miles, so 3.5 miles. For time, we're going to be putting in minutes. So the units we put in dictates what units come out. So because we've put miles in minutes for time, this answer here will be miles per minute. So whatever we work out is how many miles this car is travelling every single minute. Not hours, but minutes. So let's just work it out, shall we? So 3.5 divided by 5. Let's do this. 3.5 divided by 5, or 3.5 over 5. Should get 7/10, or 0.7. So that's 0.7 miles per minute, but obviously we want it in miles per hour. And so how do we go from minutes to hours? If you think about it, if a car's travelling 0.7 miles every minute, then it will do that same distance on average for every single minute in the hour. So how many minutes are in an hour? It's obviously going to be 60. So what we need to do here is to multiply by 60. Because in an hour, you'd be able to travel 60 times as far, because you've got 60 times as much time. So what we'll have as a final answer is 0.7 multiplied by 60. So 0.7 times 60 is 42. So we get 42 miles per hour. So that's the unit we want it in, miles per hour. So the final answer is 42. I'll just briefly mention another way, which you may have found more useful. And so average speed, you can think of it as a ratio between distance travelled and time taken. So 3.5 miles in 5 minutes. Now, just as ratios can be simplified, ratios can be built up as well by doing what we do to one side to the other side. So for example, we could build this up to 10 minutes 10 minutes is double what 5 minutes is. If we double the time, we'd be able to go double as far. So if we multiply this side by 2, we can multiply the distance by 2 as well. So 3.5 multiplied by 2 would be 7 miles. Now our target is to get it to an hour, because that's the unit we're wanting it in. So we've got 10 minutes so far. What we could do is, we could do with getting to 60 minutes, because 60 minutes is obviously an hour. So how could we go from 10 minutes to 60? We could just multiply by 6, because 60 minutes is 6 lots of 10 minutes. So if we multiply this side by 6, we can multiply this side by 6. And 7 times 6 is 42 miles. 42 miles in 60 minutes means 42 miles in an hour, which of course means 42 miles per hour. I'm not saying you have to do both ways, I'm just showing two different methods for you in case you find one easier to understand than the other. But any which way around you do it, the answer should be 42 miles per hour. Question 14 is a simple question, but what they may be trying to do is throw you off with an awkward looking triangle. But no matter what triangle you've got, no matter what the triangle looks like, the area of a triangle is always the same formula. It's base multiplied by the perpendicular height divided by 2. Your teacher might teach it as half times base times height. It's the same deal. No matter how the triangle looks, we're always going to take the base, which is 9, multiply by the height, which in this case is 5.6, and then divide by 2. Importantly, we need to divide by 2. So if we just take these numbers here, so the base is 9, height is 5.6, and then divide by 2. If we whack this into our calculator, we'll get the answer easily enough. So 9 times 5.6 divided by 2 gives us 25.2 centimetres squared. And that's the area of this triangle. Question 15, we've got 4 positive whole numbers which add up to 36. We're told that one of the numbers is a multiple of 7. The other 3 numbers are equal. And so, could the first number be 7? If the first number is 7, the total of the other 3 would be 36. Take away 7, which is 29. Now, because the other 3 numbers are equal, each number would have to be 29 divided by 3. So 29 divided by 3, that's not a whole number. You get 29 over 3. We're told clearly in the question that there needs to be 4 positive whole numbers. That's not a whole number. So the first number, which is a multiple of 7, it can't be 7. So we tried 7, didn't work, never mind. What's the next multiple of 7? Next multiple of 7 is 14. If the number was 14, the other 3 numbers would have to total 36 minus 14, which would be 22. Can we have 3 whole numbers that are equal to each other, adding up to 22? I don't think so, but if you want to check on your calculator, be my guest, you'd get 22 over 3. If you did 22 divided by 3, 7 1/3. So again, that's not a whole number. So we've tried 2 multiples of 7, 7 and 14. neither have worked. Maybe it could be 21. If a multiple of 7 was 21, the other three numbers would have to total 36 minus 21, which is 15. Now, can we have three numbers that are the same that add up to 15? The answer is yes. And so what we've got here is three numbers that are equal are 5, and the multiple of 7 is 21. And so we've worked out the three numbers here. Because when the multiple of 7 is 21, it all works. And so the four numbers, the four positive whole numbers, must be 21, 5, 5, and 5. But that's only halfway to the answer. We need to work out the result when the four numbers are multiplied. So these are the four numbers. We need to now multiply these together to get the answer. So 21 times 5 times 5 times 5, or you could do 21 times 5 cubed if you wanted. Doesn't really matter. You should get 2625. So the final answer to this one is 2625. Question 16, we've got a sketch of a triangle below. You can probably see a little clue as to what we need to do down here. What we need to do is complete an accurate drawing of that triangle ABC. And so we've been given the bottom line. The bottom line's 11. What we need to do here is make this top edge 8 with an angle of 37 degrees between. And so if I just scroll down here, so you should have that this one is 11 centimeters. What we need to do is create a 37 degree angle at A. So we put the protractor on top of A. Just trying to get it as level as I can. There we go. And what I'm going to do now is to measure 37 degrees from this point. And so start from 0. 10, 20, 30, that's 35, that's 36, 37 is here. So I need to put a little mark where 37 is. Just try and do this here. Can't seem to quite get it, which is slightly annoying. Hold on. I think I've got it there. Yeah, that tiny point. So now you've got that's 37 degrees. We put the ruler on top of where A starts and then go through and beyond that point we've just marked off. Now what we need it to measure is 8 centimeters, like we had above. And so we need to get a straight line using the ruler and do a straight line from A, going through the point we've just found using the protractor, and extend it to 8 centimeters, which is here. And so that angle now you should find is 37 degrees. Like so, and then the other line, we just join these 2 points together to get the other one. And we need to label this one C. And so your drawing should look something very close to mine in terms of the angles and the proportions. A, B, and C at the top. Question 17, we need to simplify this expression and circle the answer. So what we've done is we've done it in a slightly confusing way, I think. I think the simplest thing to do here would be to have a look inside the brackets and see if we can simplify what's in these brackets first. And the answer, luckily, is that we can. So 7x minus 3x minus 2x, we can work out the brackets first. 3x take away 2x would just leave us with 1x. And so that makes it much simpler, because now it just means 7x take away 1x would leave us with 6x's. And so the answer we need to circle here is 6x. Now, if you didn't do it that way, there is another way it could be done without simplifying the brackets. What we could do is imagine expanding these brackets out by imagining there's an invisible 1 before the bracket. I think this way is more complicated, but just in case you're interested, I'm just going to briefly show you. So, if we multiply up the bracket, 1 times 3x would be 3x, but because that one's a minus, because it's got a minus sign in front of it, that would make it minus 3x. The final term in the bracket, we do 1 multiplied by 2x, but because this one's a minus, and the 2x is minus, if we multiply a minus by a minus number, it works out to be a positive value. Minus multiplied by minus is always positive. 1 times 2x will be 2x. So then simplifying this one down, 7x take away 3x's would be 4x's, plus 2x's. Again, you should still get, but the answer to this one is 6x. Question 18. The competition took place in 1983 and took place every 6 years. Circle the year in which it will also take place. I'm going to give you a very ugly yet reliable way of doing this question. It's a calculator paper, so this isn't going to be elegant, but it will work. So we start with 1983. And because competitions are going to take place every 6 years, we can keep adding 6 until we find a value, a year, which is one we need to select. So plus 6, 1989. No, we need to keep going again and again and again. 2019, still not close. 2025 it would have taken place. That's not there. 2031. 2037. 2043. 2049 is in the list though, so we can circle 2049 as when the competition would take place. Question 19 is a pie chart question. So in an election there are 4 candidates, J, K, L and M, and Fran's drawing a pie chart to show the results. The sectors for J and K have been drawn, and for part A we need to complete the pie chart. And we're told that twice as many people voted for L as voted for M. So what we need to remember for a pie chart is that the total of all the angles of all the sectors will always equal 360 degrees, because a full circle is going to be 360 degrees. And so the angle for J plus K plus the angle for L plus the angle for M will all add up to 360 degrees. We know that for definite just by angle factors of a circle. So J, we've been told, is 72 degrees. And K, again we've been told, because the square symbol denotes a right angle, so K will be 90 degrees. So we can simplify this slightly now. So 72 plus 90 plus L plus M comes to 360 degrees. 72 plus 90, we can add these together to work out what they come to in total. So 72 plus 90 gives a total of 162. So 162 plus L plus M again comes to 360 degrees. Now we can work out what L and M must come to on their own. So if we just subtract 162 from both sides, swap side and swap sign, if you like. That 162 here is positive. When it moves, it becomes minus. And so L and M together will equal 360 take away 162. Which comes to 198. So you might be wondering as well why I've got method A written at the top. It's because I'm going to show you a different method for part A in a second. But importantly, L and M combined is 198 degrees. But now we can have a look at this thing here where it says twice as many people voted for L as voted for M. And so what we can do here is do this as a ratio. So the size of L compared to the size of M will be 2 to 1. And so what we need to do here is to split this 198 degrees into the ratio 2 and 1. So 2 plus 1 is a total of 3 parts to the ratio. And so 198 degrees divided by 3 will tell us how much each part's worth. And so 198 divided by 3 is 66. So each part of this ratio is worth 66 degrees. And so L, we've got 2 lots of 66. So we do 66 times 2, which is 132 degrees. And M, we have is 66 degrees. And so we just need to draw one sector, then whatever's left will be whatever's left for either L or M, whichever one we haven't drawn. And so using this method here, we could do M first and, for example, just measure 66 degrees. And so we put the middle of the protractor on top of where the circle is centered. And we're going to measure 66 degrees outwards. So measure from 0 and count up 10, 20, 30, 40, 50, 60. That's 65, 66 will be just here. Then we need to do a line, straight line going from the middle to the outside, to where that line would be, we've just marked. And so that is M, which is 66 degrees, and so whatever's left will be for L. So that's how the pie chart should look. I'm just going to give you a different method for how you could have worked out the angles for M and for L. So method B, again, starts with the same way. J plus K, like we said from the previous method. Oops, I'll just clear this away actually. So J plus K will come to a total of 72 plus 90, which is 162 degrees. This method now just hinges on a trial and improvement strategy. Essentially, what we can do is think what M and L must be so that the total needs to be 360. Because the total of all these angles for all 4 sectors will obviously be 360. And so what we can do is have better educated guesses each time until we land on the answer. And so what we're told here is that twice as many people voted for L as voted for M. And so all we need is a starting point, and obviously we know the answer from part A, but if we didn't know what it was, we could maybe guess that m was 50. Just have a starting guess. If m was 50, L is always going to be twice as big. So multiply 50 by 2, that would be 100. If we add up these figures, do we get to 360, which we need to? 50 plus 100 plus 162 gives us 312. So obviously 50 was too small. So maybe try 60. L is always going to be double what M is, because twice as many people voted for L. If twice as many people vote for L, that's why L will be twice the size. 60 times 2 is 120. Let's see if this now comes to 360. I'm not advising this method to begin with, I'm just advising this method in case you're really not sure what to do. And it comes to the end of a paper and you need to go back and attempt this question. I'm just trying to give you some strategies and ideas for how you can at least have a go at a question, rather than leaving it blank. Anyway, that comes to 342, so that's still a bit too low. So maybe we could try 70. So if that's 70, L would have to be double that, which would be 140. Plus 162. Now that's 372, which is too high. That's more than 360. So what we need to do, if 60 is too low, 70 was too high, we could take the midpoint. We could try 65 degrees. 65 times 2 would be 130. J plus K is always going to be 162. If we now add these together, 65 plus 130 plus 162, we get a 357, which is very close to 360 indeed, but it's still slightly too low. So if we go at 1 degree, 66, and 66 multiplied by 2, what you'd find is that that works, and that does come to 360. And so in this way, we'd still find that M must be 66, and L will be 132. So once again, just using the protractor, we can measure M, measure from 0 and go out to 66. 50, 60, that's 65, 66 is just one extra along. Then move away the protractor, get a ruler out if needed. And then with ruler, measure the angle for M. Slightly fiddly on here, but you get the idea. And so that would be the sector for M, and whatever's left will be for L. So that's M, and L double the size. Part B, we're told that altogether 16,200 people voted, and we need to work out how many people voted for J. And so what I suggest we do first of all is think of this as J, as what fraction of a complete pie chart is J. So J is 72 degrees out of the total of 360 degrees for the whole pie chart. So as a fraction, J is 72 360ths as a fraction of that pie chart. So if 16,200 people voted, it'll be this fraction of 16,200 people we need to find. So this fraction would simplify down to 1/5. You don't need to simplify it down. but we need to work out this fraction of those people. So that fraction of 16,200 comes to 3,240. And so 3,240 people must have voted for J. And that's our answer for question 19, part B. Question 20. The probability that A is the outcome of an experiment is 0.2. Circle the probability that A is not the outcome. So what we need to remember for any event is the sum of all probabilities will add up to 1. And so for any outcome for this event, it's either going to be A or it's not going to be A. You can think of it as two different outcomes. One outcome it's going to be A, the other not A. And so the probability of it being A added to the probability that it's not going to be A, so that covers all possibilities. That's got to add up to 1. So the probability of it being A, we're told, is 0.2. So the probability that it isn't A needs to be whatever number added to 0.2 that would give 1. And so we can work this out by just subtracting 0.2 from both sides. In this case, I always think of it in terms of swapping side and swapping sign, but your teacher may explain it differently, and no doubt equally as valid. So the probability of not A will be 1 minus 0.2, which will be 0.8. So that's the one we need to be circling. Question 21. Rearrange E equals 2F to make F the subject. And so if F is a subject, that just means we want the equation to be in the form F equals. So F needs to come first. In a minute, E is a subject of this equation. And so if we've got E equals 2F, and we want to have F on its own, we could move this 2 to the other side, and that 2 is multiplying the F. Opposite of multiplying is dividing, so if we swap the side of a 2, we'll swap the sign of it. Opposite of multiplying by 2 is dividing by 2. And so E divided by 2 equals F. But to make F a subject, we need to write this in the form where F is first. So if we just switch around the order that's written in and say that F equals E over 2, then we've got it. And so it's whichever one of these 4 options is the same as F equals E over 2. So it's got to be this one here, the last one. So we circle the last one for question 21. Question 22, we've got a rule for a sequence, and we're told that after the first 2 terms, each term is half the sum of the previous 2 terms. So we need to show that the 6th term is the first one, but it's not a whole number. And so in terms of the terms we've got 1, 2, 3, this will be the 4th one, 5th, and 6th. And so if we just read this carefully, we'll work out each term after by adding together the previous 2 and halving it. And so the 4th term we can work out by just doing 10 plus 6, that's the sum of the previous 2 terms, and then halving that. So 10 plus 6 divided by 2, you should find it'll be 8. So the 4th term is 8. The 5th term is the same idea. We're just looking at the previous 2 terms. So for the 4th term, we looked at the 2nd and 3rd. Add those together and divide by 2. For the 5th term, we'll be looking at the 3rd and the 4th. And so that'll be 6 plus 8. divided by 2. Well, 6 plus 8 is 14, and 14 divided by 2 will be 7. And so the fifth term is 7. Again, just by adding the previous two terms, the 6 added to the 8. But then the sixth term, so we worked out the fourth one was 8. We've just done the fifth one now, which we said is 7. The sixth term will be the fourth plus the fifth, so 8 plus 7 divided by 2. If you try this on a calculator or without, 8 plus 7 is 15. I'll just show you actually, just because you should really be using a calculator, as should I. If it's a calculator paper, may as well use it. 8 plus 7 divided by 2 gives us 7.5. And so that proves not only that 6 isn't a whole number, but we've proven that that's the first one that isn't a whole number. So we need to work out the ones before the sixth term to show that all the others are whole numbers, and the first one that isn't a whole number is the sixth term. And so this working out backs us up and shows that we've worked out the numbers correctly. For part B, we've got a different sequence, but it's following the same rule. And so the first term's 4, the third term is 9.5. We need to work out the second term. Okay, so I'm going to show you a way of doing this now. I'll show you an algebraic direct way, but first I want to show how you could do this with trial and improvement. Just to give you a few more strategies to cope with if you were to not be sure what to do in the exam. So we don't have a clue right now what that second term is. I'm going to show you a way to be more direct after, but just bear with me. So let's just say that, well, let's have a guess. Maybe that one could be 2. And so this term here is what we get is when we add together the previous two terms and half them. And so let's say maybe it was 2. What's 4 plus 2 divided by 2? Is that going to be 9.5, I wonder? Well, it's not going to be that. 4 plus 2 divided by 2 is 3, so we're nowhere near. So let's go quite a bit bigger. Let's maybe think, I don't know, maybe it could be 10. What's 4 plus 10 divided by 2? If you try this on a calculator, you'd get 7. That's still too small. So again, we can increase our guess a bit more. Let's try maybe 16. Just increase it a bit more. 4 plus 16 divided by 2. If you try that on a calculator, what you should find is it comes to 10. Now that's very close, but 10's a bit too big. So although we've not got the answer, we're at least close. So let's go down a bit. Let's try maybe 15 next. All I'm trying to show you is that by keeping on and not giving up, you'll get the answer eventually. Not on some questions, but on enough to make it a worthwhile thing to bear in mind. 4 plus 15 divided by 2 is 9.5, and that works. And so what we've proven by using this trial and improvement approach is that the second term would have to be 15 for it to work. So the answer, second term, must be 15. Now, as I did say, I'm going to show you a way using a more direct algebraic approach. So if I just get rid of this for a second, and let's say we wanted to use algebra and call this something, I don't know, If in doubt, call it x. And so what we're told here is each term is half the sum of the previous two terms. So relative to 9.5, if I just take this over here where I've got some more space, just move to the top of the page for a second. So each term is half the sum of the previous two terms. So compared to 9.5, the previous two are 4 plus x. So half of that sum would be 4 plus x divided by 2. And that needs to give us 9.5. Now this is an equation we can now solve. So all of that 4 plus x is being divided by 2. If we swap side and swap sign, that 2 which is dividing here becomes the opposite of dividing, which will be multiplying. After this 2 moves across, we'll just be left with 4 plus x. On this side now, we'll have 9.5 multiplied by 2, which should be 19. Now the final step would be to knock 4 off both sides, or you can think of it as that positive 4 swaps side and swaps signs to a minus. So x will be 19 minus 4, which is 15. So whether you use a trial and improvement approach or a direct approach, the second term needs to be 15. Question 23, we've got a Venn diagram which has been done wrong. So in a group of 20 people, we're told that 7 own a dog, 3 own a cat, and 12 do not own a dog or a cat. So he's shown this information, and we need to make 2 criticisms of his Venn diagram. The first one to me, which is most obvious, is that 12 is outside of the diagram. That 12 needs to be inside the rectangle. So I just say 12 needs to be inside the rectangle, not on the outside. Secondly, if it's 20 people, these numbers here should add up to 20. So 7 plus 3 plus 12 adds up to 22. It should add up to 20. Now that should do. That should do as a fine criticism, but if you wanted to go one step further, if you really wanted to explain why, you could take this further if you wanted to. I just recommend leaving it like this, to be honest, but what I could say is that some people must have owned a dog and a cat. So because we're 2 over the 20 limit, what that means is that some of these people here must have owned a dog and a cat. And so we can put this in here. So two people must own a dog and a cat. In terms of making this Venn diagram correct, what it should look like is this. So that 12 should go on the inside. 7 own a dog and 3 own a cat. Fair enough, we're not saying that's not right. What it should look like is that of these 7 people own a dog, 2 also own a cat. So 5 plus 2 gives us 7. And 1 plus 2 gives us 3 for the cat. But now 5 plus 2 plus 1 is 8, plus that 12 gives us 20. So that's how the Venn diagram should look. And obviously it doesn't look like that. And so that's another way of thinking about what mistakes have been made. Question 24. We're told that A is a common factor of 72 and 120. and b is a common multiple of 6 and 9. Work out the highest possible value of whatever a over b is. So for this one, if we just think of a first, and think of the factors of 72 and the factors of 120. With a calculator, working out factors is much easier because we can just divide by 1, divide by 2 as quickly as we like. Anyway, using a calculator, you should find that 72 divided by 1 is 72. Any number divided by 1 is just itself. We can also divide 72 by 2, which would give us 36. 72 can also be divided by 3. That would give us 24. 72 would also divide by 4, which gives 18. And 72's got a lot of factors, as you can see. We can also divide that by 6, which should be 12. And finally, 72 we can divide by 8, which should give us 9. That can be easily checked with a calculator, just dividing 72 by different things each time. The next thing we could divide 72 by would be 9, which should give 8, but because we already got 9 and 8, that proves that we've got them all. 120, again, factors of 120. Just do this quickly so you've got the idea. 1 and 120. We'd have 2 and 60. 3 and 40. 4 and 30. We'd have 5 and 24. 6 and 20. We'd also have 8 and 15. And the final two, running out of space, so I'll just put them up here. We'd also have 10 and 12. So lots of different factors of each of these numbers. And so we're wanting common factors. And so let's have a look at which ones we can see in each. By the way, because we're wanting the highest possible value of a divided by b, what we're wanting here is to find the highest common factor. And so the highest factor here is 72 and 120 here, but there's not 72 and 120 in each. And so that's not a common factor of each. If you keep scanning through, you should eventually find that the highest common factor is 24. Because 24 is in each list. 36 and 72, they're the only ones higher, but they're not in the factors of 120. So the highest common factor for what a could be is 24. And so a must be 24. Now b is a common multiple of 6 and 9. So think about what b is. Multiples of 6 are 6, 12, 18 and so on. Multiples of 9 are 9, 18, 27 and so on. So for b, a common multiple for b is 18. In fact, 18 is the lowest common multiple of 6 and 9. What we're trying to find here, the highest possible value of a and b, will be when a is at its biggest and b is at its smallest. And so what we've really found here is the highest common factor of these two numbers, which is a, which will be 24, And the smallest thing we can divide it by, the way to keep it as big as possible is to find the smallest thing to divide by. That's going to be the lowest of the common multiples of 6 and 9, which is 18. And so 24 divided by 18 is the highest possible value of A and B. So we can do this on the calculator. 24 over 18 would be 4/3. And that's the answer for the highest possible value of A and B. If you wanted to, you could give it as a mixed number, but I think 4/3 would be the easiest way to write it down. Question 25. We're talking about similar shapes here. A and B are similar. So what this means is that one is an enlargement of the other. And so, as it says, in fact, B is an enlargement of A with scale factor 1.5. All that means is, to get from A to B, because B is bigger, you'd have to multiply by 1.5. And the converse of that, to go the other way around, from B to A, from a bigger thing to a smaller thing, we'll have to divide by 1.5. One thing important to remember, when shapes are similar, the angles are the same. So similar implies that the angles won't change. Angles are the same. That's really important. A common mistake is just to multiply everything by the scale factor of enlargement. But if you have a look here, they even look the same angle. That's not got any bigger or smaller. So for example, just to illustrate this, if I had a square, each angle's 90. If I enlarge that square, the angles aren't going to change. It's always going to be 90 degrees, no matter what the size of the square is. So be really careful. That's a trap that you can easily fall for. The angles aren't going to change. So angle X will still be 54 degrees. It'll be exactly the same, because one of them's 54 degrees. The corresponding angle in the bigger shape will also be 54. We need to work out H as well. So we know 5 on the small shape, H is on the bigger shape. And so this side here on the small shape corresponds to H on the bigger shape. And so to go from the small to the big one, we need to multiply by 1.5. And so H will be 5 times 1.5, which is 7.5 centimeters. And for W, what we're going to do is go from the bigger side on the big shape to the corresponding smaller side on the small shape. So to go from the big to the small, we're going to be dividing by 1.5 this time. We're going the opposite way around, so we're going to do the opposite thing and divide. And so 9 divided by 1.5 should tell you that W is 6 centimeters. And that's question 25 done. Question 26 I'm going to show in one of two different ways. So the first way I'm going to show you is a way which is just quicker. It's going to be using decimal multipliers. For method B, I'm going to show you a table method. So we've got two different investments, investment A and B. So I just section them off here. So for investment A, we save £150 per month for 2 years. So £150 per month. So for 1 year, there's 12 months in a year, so we could multiply by 12 to find out the yearly total. And for 2 years, multiply that by 2. So 150 times 12 times 2 is 3,600. Now, 2.5% interest is added to that total that's saved. And so we can work out 2.5% of 3,600 and then add it on. 2.5% of 3,600. Percentage means a fraction out of 100, so 2.5 on top, out of 100. That percentage, not out of 1,000. My mistake. 2.5% of 3,600 comes to 90. So the total for A is going to be 3,600 plus the other £90, which is 3,690. So investment A, we end up with this total. We can now compare that for investment B. It's compound interest added at 3% per year. So if 3% gets added, remember we always start with 100% of the value. So 3% is added, we can think of the original 100%, 3% added, which comes to 103%. Now, as a decimal, we can change from a percentage to a decimal by dividing it by 100, and the decimal equivalent is 1.03. And that's for what's often called in textbooks, and maybe by your teacher, that's for decimal multiplier. To find 3% increase, you can multiply an amount by 1.03. Multiplying by 1 keeps it as itself, 100%, and the 0.03 adds on the 3%. And so the amount for B, after 1 year, we could multiply by 1.03. But because we're going to invest it for 2 years, it says after 2 years, we multiply by 1.03 twice. And so we could do multiply by 1.03, multiply by 1.03, but the quicker way is to do multiply by 1.03 squared. And that squared comes from the fact that we're talking about 2 years. If it was after 3 years, that would be to the power of 3, and so on. And so 3,500 multiplied by 1.03 squared comes to £3,713.15. But the question asks, how much more is investment B than investment A? So we've worked out B. So how much more is B than A? That's just the difference between them. So £3,713.15 subtracted from 3,690 will tell us how much more investment B is compared to investment A. And so if we do this one, subtract from 3,690, we will find that there's £23.15 difference between them. So that's how much more investment B is worth than investment A, £23.15. I'm now going to show you a second method which is a bit slower but perhaps easier to deal with. So if you're thinking, well, Sean's not shown me this way in class, it's because I favour method B. Method A is much quicker, but method B I'm going to show you now. So this is method B. So I'll do investment A first, £150 per month for 2 years. So £150 per month, multiply that by 12 months of the year, so this will be how much is saved per year, and for 2 years, multiply that by 2, and we'd get 3,600. We then add 2.5% interest onto that afterwards. So now we can work out 2.5% of 3,600 and add that back on. So once again, percentage just means out of 100. So 2.5% means 2.5 out of 100, and that multiplied by 3,600, which is 90. And so the total of investment A after 2 years is 3,600 plus that extra 2.5%, the extra 90, which comes to £3,690. And so that's investment A. Now for investment B, this is where the second method comes in. You can do it as a table of values. This is what I prefer to do because it just keeps it simpler. It might take longer, but it makes it slightly less complicated. So it's slower, which is a downside. The upside is I think you're probably less likely to make mistakes here, and it's easy to pick up method marks too. And so we're talking about 2 years. So it says after 2 years, so year 1, year 2. So the interest rate is not going to change, it's going to be 3% per year. So for year 1, the interest will be 3% of 3,500. Because that's what we start with. So at year 1, we start with 3,500. 3% of 3,500 we can work out by just doing that fraction of 100. 3% means 3 out of 100. That fraction of 3,500 comes to £105. So at the end of year total, it'll be the £105 extra added to what we had to start off with. So 3,500 plus 105 comes to a total of 3,605 pence. So what we end up with at the end of year 1 is what we'll start off with at the beginning of year 2. So now the interest for year 2 will be this percentage, but now of this bigger amount. So we're talking now of 3% of 3,605. So the same percentage, but this time of a slightly bigger amount. 3% of 3,605 comes to £108.15. And the final end of year total after year 2 will be the £3,605 we began with, plus this £108.15. So we started off with 3,605, and the total £3,713.15. And so investment B ends up being £3,713.15. The ultimate question though is, after 2 years, how much more is investment B than investment A? How much more is this one here than 3,690? We can calculate that by just doing investment B's end total, take away investment A's grand total. We'll just work out the difference between them. So £3,713.15, subtract 3690, and we get £23.15. And so whether you use method A before or method B, we should find that the difference between these two investments, the answer is £23.15. Question 27. We need to show that these two lines are parallel. Do not use a graphical method. I've got no doubt that somewhere in your school education you will have been told about y equals mx plus c. If you haven't, then I'm mentioning now anyway. Essentially, any straight line can be written in this format. And when a straight line is written in this format, the number in front of the x, which is often called m in textbooks, m is the gradient of the two lines. And not that you need it for this particular question, but I may as well mention now. C is the y-axis intercept. That's just a fancy way of saying that's where the line crosses the y-axis. Now, when two lines are parallel, what that means is the gradients are the same. So if two lines are parallel, the gradients are the same, and we've just mentioned a second ago that when a graph is written in this form, that the number in front of the x tells us what the gradient is. And so what we can do here is just rearrange both of these lines to this form and see what the numbers in front of the x's are. And so the first one, y equals 3x plus 7, that's already in the form y equals mx plus c. So for that one, the gradient, the number in front of the x, is 3. For this second equation though here, this needs rearranging. And so this second equation, so far we've got 2y minus 6x equals 8. What we need to do is to get the minus 6x's to the other side of the equation. Now these 6x's are minus because we've got a minus sign in front of them. So when we swap side, we swap sign and they'll become plus. They'll become positive. And so what we'll have now is 2y equals 6x plus 8. But we don't want to have just 2y, we want to have just 1y. And so what we can do is just half both sides of the equation. Effectively, that 2 is multiplying the y. Because it's multiplying on this side, when it swaps over, it'll be dividing everything on the other side. And so in the form y equals mx plus c, if we half both sides, half of 2y is y, half of 6x is 3x, and half of 8 is 4. And so when I've rearranged this equation here and got it in the form y equals mx plus c, you should find that the equation of it becomes y equals 3x plus 4. So for the equation I've highlighted in light blue, the gradient is 3 because the number in front of the x is 3. For the equation I've highlighted in purple, the number in front of the x is also 3, which proves that we have the same gradient. They both have a gradient of 3. The pen's going a bit strange. Both have a gradient of 3. Now for part B, we're asked if a point is above, below or on the line of y equals 3x minus 7. And so if we have a look at this point first of all, this is a coordinate, and coordinates are always given x first, followed by y. And so we've got -5, -6, which is the point we've been given, so we can just imagine that as being -5, -6. What we can do now is think, what would y be when x is -5 on this line? And so for this graph, we can think, what would y be when x is -5? When x is -5, y is just 3 times -5 plus 7. This is a recipe, if you like, for working out what y is for any value of x. So for this particular line, y is always x multiplied by 3 plus 7. And so we can work this out and see what y would be on this line when x equals -5. So 3 multiplied by -5 plus 7 equals -8. And so on this graph here, y equals 3x plus 7, it looks something like this. And so what we'd have here, in fact I'll just make a bit more space. So that we can picture as being -5, -6. But when when x is -5 on this graph, y is further down at -8. When x is -5 on this line, y is -8. So this point here is actually above the line. If this were the line y equals 3x plus 7, the point we've been given is 2 units above, because -6 is less negative than -8. So -6 is slightly higher up than -8. So we need to tick above the line. Question 28, we've got a cost of a ticket which increases by 10% to £19.25. Before anything happens to a value, we always start with 100% of itself. So if 10% gets added on, it's going to be an increase. But remember, we always start with 100%, and so if we add on 10%, 110% is the final value. And so the increase represents 110% of the price. And so this £19.25 will be 110% of the original. So we can say £19.25 equals 110%. 100% plus an extra 10. What we could do with finding out is what 1% would be worth. So how could we go from 110% to 1%? What could we divide 110 by to get 1? Well, the answer to that is that any number divided by itself will always give 1. And so what we can do is just divide by 110 to find out what 1% is. But to keep this in the same proportion, if we divide over here by 110, we need to divide the amount too by 110. So £19.25 divided by 110 we get 0.175. Don't root at this stage if it doesn't look like a normal amount of money, because we're not finished yet. But don't round it off yet either. So 0.175 is 1%, Now we can work out what 100% is. To go from 1% to 100%, we just need to multiply by 100. What we do to one side of this relation, we need to do to the other side as well, to keep it in balance, to keep it in proportion. And so 0.175 multiplied by 100 would give us £17.50, 17.5. And 17.5 in terms of money will obviously mean £17.50. And so that's the original price, £17.50. Question 29, about the nth term. So we've told what the sequence is. It's 12n minus 5. You need to work out the numbers in the sequence that have 2 digits and are not prime. And so 12n minus 5, the first term, you can actually work out the terms here. First, second, third, fourth, fifth, sixth, and so on and so on. So working out all these terms, the first term is just 12 times 1 minus 5, which is 7. The second term will be 12 times 2 minus 5, because n is 2 when it's the second term, get 19. The third term is 12 times 3 minus 5, which is 31. So we can keep on working out the values by substituting in for different values for n for what we want the terms to be. But just trying to refresh your memory about the nth term, the number in front of the n will tell us what the numbers are going up in each time. So the numbers will be increasing by 12, as they are, as you can see. But because it's a minus 5, each number in the sequence will be 5 lower than the corresponding value in the 12 times table. So the 12 means it's going up in 12s, like the 12 times table, but the minus 5 means we start 5 lower than 12. So either by substituting in the values or by just adding on 12 each time, you should find that you get these values for the sequence. 79. The next one, the 8th one, will be 91. And the next one over here will be 103. Let's have a look at the criteria of what we want these numbers to be. It needs to be 2 digits. So that limits it to these now. And they can't be prime. So is 19 prime? Well, 19 is prime, but I'm going to show you a neat way how you can check with a calculator if a number's prime or not. You can type in the number, press equals, and then if it's prime, if we press shift and fact, nothing should happen, because this finds a prime factorization of a number. So if nothing happens, then it's already a prime number. So shift fact, 19 just stays as it is. And so 19 is a prime number. 31 equals shift fact. 31 again is prime. Is 43 prime? 43, press equals, shift fact, 43 is prime. You should know really that 55 isn't prime, but you need it to check. Press 55 and equals, shift fact, it changes. 55, for example, can be divided by 5 and 11, and so 55 isn't prime. How about 67? Looks prime to me, but if you're not sure, press 67 equals shift fact 67's prime. Is 79 shift fact 79 is prime, is 91 prime. Press 91 then equals, and shift fact 91 isn't prime, you see, because we can divide 91 by 7 and 13. And so the numbers that have 2 digits and aren't prime in this sequence are 55 and 91. And so that's the numbers we need to write down here, 55 and 91. Finally, the last question. We've got 3 different vectors here. We've got vector A, B, and C. The first thing we need to do is work out A plus B plus C. And that one is more straightforward than what it might seem. All we do when we add vectors is we add the numbers together. So A plus B plus C, we need to add the top numbers, 6 plus minus 1 plus minus 4. The bottom numbers, minus 10 plus 2 plus 7. So I'm just going to highlight where these numbers have come from. So 6 and minus 10 is A, B is minus 1 and 2, and C is minus 4 and 7. Now with negative numbers it can be quite confusing, but I'm just going to remind you of what calculators can sometimes do. So for example, calculators used to not like you putting positives and negatives together. But for example, these days, with a good enough calculator, the calculator can process it for you without no problem. And so once you've got faith in your calculator, you can work these values out by just typing it in as it appears. 6 plus minus 1 plus minus 4 gives us just 1. So the top number is 1, and the bottom number, minus 10, is what we start with, plus 2 plus 7, that gives us minus 1. And so A plus B plus C is just 1 minus 1. Part B, show that A plus 2C equals KB, where K is an integer. Well, if C is minus 4 and 7, 2C means 2 multiplied by C. And all we need to do here is just multiply the top and the bottom number by 2. It's like we're expanding brackets in a way, we're just multiplying each number on the inside by this number what's on the outside. So 2 multiplied by minus 4 is minus 8, and 2 multiplied by 7 is 14. And so A plus 2C, A is 6 minus 10, and 2C, we're going to just add on, so plus minus 8, and then plus 14. So if we do these calculations again with a calculator, 6 plus minus 8 is minus 2. And the bottom one, minus 10 plus 14 gives us 4. So K just means a whole number which can be negative. So can we factorize this out where K is a factor, so that this one here looks like B? And so minus 2 and 4, again, what can we divide 2 and 4 by? 2 and 4 have a common factor of 2. So if we take 2 on the outside and think we've got 2, we want to end up with minus 2. Well, 2 times 1 would give us 2. But because it's a minus 2, you need that to be a minus 1. And 2 multiplied by something gives us 4. That would be 2 times 2. And so, essentially, k equals 2. And b is what we've got here, because b is minus 1 minus 2. So when we factorise a plus 2c here, we get 2 lots of vector b. And so this just proves that when you do the arithmetic, it drops out as 2 lots of vector b. And that's the question complete, and therefore the whole paper completed. I hope you found that useful, and I do hope you've done okay and will get what you need in these exams. Put it at the back of your minds, wait till results day, and I do wish you all, genuinely, I wish you all the very best of luck. Feel free to comment, subscribe and leave any comments. I'll get back to you as soon as I can. Thanks for listening.